Hi fams, in this very lesson, you're going to be looking at balancing of complex redox equations. In our previous set of lessons, we worked extensively on how to balance simple redox equations, which is also known as the neutral, redox equation. But in this very lesson, you're going to be looking at complex redox equations, that is, redox equations in either acidic medium or alkaline medium. So we have a question right here on the board. There's a very first question. We are asked to balance CR2O7, 2 minus, that's aqueous, plus Fe, 2 plus, another aqueous, the 2 of them coming together to give us CR3 aqueous plus Fe, 3 plus, another aqueous, both in acidic and alkaline medium. Now the question is, how do we get to know when they are both in acidic, when they are either in acidic or alkaline medium? Now the fact is this, we can easily get to know just by looking at the equation. Although, what really tells us that we are working on a complex equation, not a neutral or the simple equation like the other set of questions, is simply the presence of this oxygen. So most time when you have an oxygen attached to probably a metal or a non-metal, it means you're working on something complex. So either an oxygen or a hydrogen. So when we have this attachment, if you look at the previous set of lessons, if you have not seen them, I'd love you to go back to see them, to have a look at them. You find out that there's no oxygen or there's no hydrogen. But those complex ones, you have an oxygen attached to either a metal or a non-metal. So now the fact is this, we are going to be told if the equation is either in acidic format or alkaline format. So let's see what we mean by equation being acidic or alkaline format. So an equation in acidic format is simply an equation that has a pH of a pH lesser than 7. This is what we mean here. So if the equation is in acidic format, if you're talking about an equation in acidic medium, actually, it means you're talking about an equation that has a pH less than 7. We are talking about something like this. Let's get a scale for it, for this acidic medium redox equation. So you're talking about 0 lesser than or equals to this pH here, or lesser than 7. So what does this simply mean? It simply means that the pH, look at 0 lesser than or equals to this pH. So it means you're talking about a pH that is either equals to 0 or greater than 0, but not equals to 7, lesser than 7. So we're talking about an acidic, medium redox equation. The pH is simply between 0 to 6. That's what we're talking about for acidic medium redox equation. While for basic or alkaline, whichever word you want to use, either alkaline or basic, they are all, they are the same thing. So for basic or alkaline, we're talking about the pH being higher than 7, not more than 14. Don't forget, according to Sorensen, the table, the pH scale, according to Sorensen, you have a scale between 0 to 14. So for basic, the pH is, more than 7. 7 is neutral. So we have something like this. We have 7. 7, this is a pH here. Then that's what we have. So we have something greater than 7. So you have 8, so just simply between 8 to 14. So you can say the redox equation is an alkaline or basic medium. So sometimes we're not going to be told, we're just going to be given a pH. So if you're given the pH between 0 to 6, it is acidic. If you're given the pH between 8 to 14, it is alkaline. A pH of 7 is neutral, just like the set of ones we worked on, the previous ones. So that's the first thing. So the next thing I would love us to look at quickly before we solve this very equation, don't forget, we are asked to balance what we have right here on the board, both in acidic and alkaline medium. So we're going to assume that this very stuff, first of all, is an acidic medium, and later on we're going to solve it in alkaline or basic medium. So now there's something we have to look at. Now when it comes to acidic medium, we're going to talk about acidic medium, a redox equation acidic medium. There's something I want us to focus on. Now, on the reduction end, we're going to look at the reduction first, the reduction end. So this reactant on the reduction end, there's a product on the reduction end. So what do we do when it comes to acidic medium redox equation? So we're talking about reduction, this reduction first. So when it comes to reduction, we are going to add H plus this, nice. We're going to add this, we are going to add hydrogen aqueous, this hydrogen ion to this, then water to the other side. Hydrogen ion will be added to the reactant and water liquid will be added to the product. That's that for the reduction. While for the oxidation, we're going to have a swap in roles. H2O will be added to the reactant while hydrogen ion aqueous will be added to the product. This is how it's done when it comes to reduction and oxidation under acidic medium. So when it comes to basic medium or alkaline medium, this is how we go about it. For basic medium, this is what we do for basic medium. So for basic medium, we're going to do something different. We're going to do the opposite of what we do when it comes to acidic, medium. So under the basic medium, it's going to extend this very table. So when it comes to reduction, under the basic, or alkaline medium, for reduction, don't forget we have the reactant and we have the product, just like what we have here. So when it comes to basic medium, on the reactant end, we're going to do something different. We're going to add water first to the reactant. It's going to be water first, H2O on the reactant. And this time around, on the product end, we are not adding hydrogen. Unlike this hydrogen ion aqueous, we're not doing that. Hydrogen, the presence of hydrogen shows acidity. But this time around, we're going to be adding hydroxyl ion, OH, minus, plus water this time around. We're not adding only hydroxyl ion, we're adding hydroxyl ion accompanied by water. So that's what we're going to do on the reduction end. That's for reduction. Now, when it comes to oxidation, what do we do when it comes to oxidation? We're going to swap their rules also. This will come over while this comes over to the other side. So for the oxidation, we're going to be adding hydroxyl ion plus water. That's on the reactant end, while on the product end, we're going to add water to eat. So these are the basic things you have to know first for us to be able to balance, redox equation in acidic and alkaline medium. So for acidic medium, on the reduction end, that's H plus hydrogen ion will be added, then water will be added to the product. Oxidation, water added, hydrogen ion added. That's that for acidic medium. Now for basic medium or alkaline medium, water will be added to the reactant. Hydroxyl plus hydrogen plus water, I beg your pardon, will be added to the product. While for the oxidation, we're going to swap their roles. Hydroxyl plus water added to the reactant, water added to the product. So quickly, let's solve this question we have right here on the board. Let's take off what we have right here. So it's time to solve this. First, we're going to solve it in acidic medium. And after that, we solve it in the basic medium. First of all, acidic medium, and after basic medium. So this acidic medium. So what do we do next? Let's write out this question. The Cr2O7, 2 minus aqueous, then plus this Fe, this 2 plus aqueous, Cr3 plus aqueous plus Fe3 plus aqueous also. So the first thing we're going to get is we're going to get the oxidation number for each of them. Now we're talking about this chromium first. What's the oxidation number of this 2 atoms of chromium? So oxygen here is minus 2 times 7 is minus 14. You have a charge of minus 2. We send this to the other side. Plus 14 minus 3 is plus 12 divided side by 2. We did this already in our previous set of lessons. You can go ahead and see valencies and oxidation numbers. So this is plus 6. Oxygen here is minus 2. We don't really have a business with oxygen. It's not a part of it, directly. So iron here is plus 2. Chromium here is plus 3. Then iron here is plus 3. So when we look at this, the Cr2 here, the chromium, from plus 6, I beg your pardon, to plus 3, there's a reduction. This experience a reduction, RED. While the iron, from plus 2 down to plus 3, experience an increment in oxidation number, which is what we call the oxidation. So how do we solve it? I'm going to write each of them out. The Cr2O7, 2 minus, equals to Cr3 plus over there. So the Cr2O7, 2 minus, which is an aqueous, then equals to Cr3 plus, which is another aqueous. So plus 6 down to plus 3. So how do we explain this? Oxidation number moved from plus 6 to plus 3. So that means 3 was subtracted from this very 6 to give us this. So how do we do that? We do that by adding 3 electrons. We did that already in our previous set of lessons. So let's do that on this very end. The Cr2O7, 2 minus, which is aqueous, plus 3 electrons equals to Cr3 plus another aqueous. So don't forget, our focus is on the chromium, which is Cr2, and our focus on the Cr, that's the chromium on the reactant and on the product end. So don't forget, we have 2 atoms of chromium here, and here we have 1 atom. We're going to add 2 to this base to make it balanced. So you're just going to do the same thing. You times the electron by 2. So you have the Cr2O72 minus now plus 6 electron equals to 2Cr3 plus aqueous. As you can see, this is balanced. We have 2 atoms of chromium and then 2 atoms of chromium here also. Why we have 6 electron, it should be balanced on the norm. But for the fact that we're dealing with a complex redox equation, we have the presence of 7 atoms of oxygen on the reactant end. So how do we balance this out? Because you have oxygen here on the reactant end. And that's why what we discussed, what we said at the beginning of this lesson, really coming to help us here. Since you're talking about, what are we talking about here? You're talking about reduction. When it comes to acidic medium, for us to balance out either the oxygen or hydrogen under reduction, what are we going to do? We're going to add hydrogen ion to the reactant and then water to the product. That's what we're going to do now to balance this out. So it's going to be Cr2O7 2 minus plus, then we're going to add hydrogen ion. That's another aqueous plus 6 electron equals to 2Cr3 plus, then plus water. That's what we do when it comes to things like this. Every other thing is settled just for the fact that we have 7 atoms of oxygen. We have to look for a way to balance it. So the only way we're going to do that is by adding hydrogen ion to the reactant and water to the product end. Why? For the oxidation, we're going to swap it. Water comes to the reactant, hydrogen ion goes to the product end. So the next thing we're going to do now, we're going to balance this. We have 2 atoms of hydrogen here. We have 1 atom of hydrogen. What I'm going to do, we're going to add 2 to this. So this is balanced already. So what do we do next? After that, the next thing we're going to do, the 2 atoms balance. Then oxygen here is 7. Oxygen here is 0. Let's add 7 to this. Nice. Oxygen now is 7. Hydrogen is 14. Okay. Hydrogen here is going to become 14 then. So I think the hydrogen is balanced, oxygen is balanced, and the chromium also is balanced already. Became balanced right from this very spot. So this is balanced. Everything is set out. 2 atoms of chromium, 2 atoms here, oxygen 7, hydrogen 14, hydrogen 14. We are done with the reduction end, this equation 1. So quickly, let's look at the oxidation part. When you look at the oxidation part, there is no oxygen present. There's no oxygen here. So for the fact that we don't have oxygen, it means this is straightforward. So here plus 2, became plus 3. So that means 1 was added to this. So how do we add 1 oxidation number? That's going to be 1 electron added. So that's going to be Fe2 plus minus 1 electron equals to Fe3 plus here. So when you look at the number of atoms, 1 atom of iron, 1 atom of iron, everything is well set out. This is so straightforward, very straightforward. So we have this well set out. Assuming you have the presence of oxygen or hydrogen attached to one of them, to either the ion in the reactant or ion in the product. So that means you're going to need these 2 people also. We're going to need the hydrogen ion and the water also. That means water will be added to this and the hydrogen ion will be added to this. Just a swap of what happens on that reduction. So everything here is well set out. We have equation 2. So what do we do next? We're going to bring them together, equation 1 and equation 2. So how do we balance that? 6 electron, 1 electron. So what do we do? Times this by 1, then we times this by 6. So times this by 1 and this by 6. So we're going to express them out like this times 6, and that's times 1 of them. So 1 times all this will give us Cr2O7 2 minus plus 14 hydrogen ion, don't forget, plus 6 electron equals to 2Cr3 plus 7H2O. That's what we have then. 6 multiplies all this. We end up having 6 ion plus, that's minus 6 electron equals to 6 ion 3 plus, like this. So everything is well set out. We have everything well set out. We just use the elimination method. So electron plus 6 electron minus 6 electron, we're going to add them together to eliminate those electrons. So this takes out this. So we end up having Cr2, that's our atoms, 2 minus, then plus 14 hydrogen ion, then plus 6Fe2 plus, then equals to, we have the 2Cr3 plus water, H2O, then plus 6Fe3 plus. So this is it on the reactant, and this is it on the product. So we have hydrogen here, we have water here, everything is well set up. So this is how to balance this in acidic medium, as simple as A, B, C, as easy as that. So quickly, we're going to be looking at how to balance this in alkaline or basic medium. Okay, guys, let's quickly solve this in alkaline medium also. We solved this already in an acidic medium. So let's look at how we can solve this in alkaline or basic medium. So we're going to write the same, the same question out. Cr2O72 minus an aqueous right here plus Fe2 plus aqueous equals to Cr3 plus aqueous plus Fe3 plus. So I tell you the fact this is going to be more complex than the very first one because this is alkaline medium. So how do we do it? The first thing we're going to do, don't forget, we have to get our station numbers first, which is discussed out already. Plus 6 here is minus 2. There's plus 2, plus 3, then plus 3 also. So here we have a reduction. This will be a reduction. Right here we have the oxidation, OX. So don't forget this is alkaline medium. We are talking about alkaline medium. So we assume that this redox reaction took place in alkaline medium. Now we've already worked on acidic medium. So how do we solve this? Provided this is in alkaline medium. Don't forget that we're going to be told. It's now we are being told or we are going to be given a pH. So the pH tells us if it's alkaline or acidic. So how do we solve? Let's attend to the reduction end first. The Cr2O7, 2 minus, gives us Cr3 plus. So plus 6 moved down to plus 3. It's a reduction of minus 3. We talked about that already. So how do we explain this reduction of minus 3? That's going to be Cr2O7, 2 minus, plus 3 electron to bring about Cr3 plus on this other end or on this other side. So what are we going to do next? Now we have oxidation here. We have oxygen here, I beg your pardon. Oxygen here makes this whole thing complex. So how do we balance out this oxygen? And that's what brings us to this very point. We discussed this already at the beginning of the lesson that when it comes to alkaline medium, under reduction, this is reduction we are talking about. For reduction, we're going to do something. We're going to do something different. Unlike the acidic medium, whereby we add hydrogen ion, that's H plus, then water to the product end. But this time around, we're going to do something different. We add water to the reactant, and then hydroxyl ion plus water to the product. So that's what we're going to do here. We're going to do something different. So that is Cr2O7, 2 minus, plus water. We're adding water to this place. Then plus 3 electron. Then we have the chromium here, which is 3 plus. After adding water, now this is alkaline medium. This is not acidic medium. So we're going to be adding hydroxyl ion minus plus water. It's advisable for us to put these two in bracket. It shows that they are both 1. If you separate them out, if there's no bracket, you may find it difficult to balance this whole setup, this equation. So we have hydroxyl ion plus water on the other end. We have water on this very end here. This is the whole layout. So don't forget the chromium here is 2 atoms. Our chromium here is just 1 atom. So you can easily do this first. You can add 2 to this place to balance all the chromium. So when we do that, we're going to times this by 2. It makes this become 6 electron. So that's it. We should have done that already from this very spot. But it's fine. We are still right on track. So we are going to look for a way to balance this whole equation up. I could use the trial error method that we use while we are solving this under the acidic medium. But I don't want to waste my time. I'll just go directly and use the algebraic method. So this is A. This is B. It's not going to take part in this. This is C. We're going to leave this out. This is D. So first we're going to attend to the chromium. Let's quickly do that here. The chromium ion, there's 2 atoms of chromium, 2A. No other chromium here. Then on the product end, we have 2 atoms of chromium, which is 2C. You're done with that. That's equation 1. Then the oxygen, we have 7 atoms of oxygen, 7A. Then you have oxygen here, also 1 atom, plus 1B, equals to, then the product, we have 1 atom of oxygen here, plus another 1 atom, that is 2. We're done with that. We're done with oxygen. Then the hydrogen, 2 atoms of hydrogen, which is 2B. Then we go to the product end, no other hydrogen on this very end, on the reactant end. So we have 1 atom of hydrogen here plus another 2 atoms. So hydrogen here, altogether, we have 3 atoms of hydrogen, no attachment, no coefficient. So it's 2B equals to 3. We're done with all the atoms of reactant element. So what do we do next? You have 2A equal to 2C, which is equation 1. 7A plus B equals to 2. equation 2, and now this equation 3. So we're good to go. 2b equals to 3, it means b automatically is 3 over 2. That is well set out. Now 2a equals to 2c. If 2a is equal to 2c, 2 can take out 2. It means a is equals to c. So we're going to come down to this very place. We have 7a plus the b is 3 over 2 equals to 2 over 1. So we can do something. We can send this to the other side. 7a equals to 2 minus 3 over 2. 7a is cross multiply 4 minus 3 over 2. So we have 1 over 2 divided both sides by 7. The a is 1 over 14. That's our a. So if a is 1 over 14, it means c also is 1 over 14. So just come in here and fixing the whole thing. So we have the a to be 1 over 14. CR207, 2 minus, plus the b. The b is 3 over 2 times H2O plus 6 electron equals to the c. What's the c? The c is 1 over 14 also. Right here, we have 2 electron also, don't forget here. On the C end, we have 2 electron here. So times 2Cr right here, then plus, what do we have here? The OH plus H2O. So you have everything well set out. So you have the A, you have the B, you have the C. So we're going to get the LCM 14 to 14, which is 14 also. So LCM is 14 times 14 times 14. Then this is going to be, it's not a part of it. This times 14, then 14. So 14 takes out 14, 2 here, 1. Between 14 and 7. 14 takes out 14. What do we have? Cr2O7, 2 minus, plus. Then there's 3 times 7, 21 atoms of water, plus 6 electron equals to just 2Cr plus. Then this 14 can share out, and then 14OH plus 14H2O. Don't forget that it's hydroxyl ion. So let's see this balance. Chromium 2 balance. Oxygen 7 here, 21 times 1 here, 21. Oxygen altogether 28. Oxygen 14. Oxygen here 14, 28 atoms of oxygen altogether. Hydrogen is 42 atoms. Hydrogen here 14. 28 plus 14, 42. Super balanced. So we're done with this. So everything is well set out here. So what do we do next? The next thing we're going to work on, we're done with the reduction. So next thing we're going to be looking at the oxidation. So this is our result for the reduction. So we're going to be looking at the oxidation right away. So when you look at the oxidation is still the same thing. If you look at the iron, let's quickly work on that. The iron is Fe2 plus aqueous equals to the iron also here, Fe3 plus aqueous. So we have from plus 2 down to plus 3. So 1 was added. So 1 electron was added, so we're going to do that. So just Fe2 plus aqueous minus electron equals to Fe3 plus aqueous. So 1 atom of iron, 1 atom of iron. This is balanced. There's no issue at all with this. So we have equation 1, and we have equation 2. So we're going to take out this portion of the board and move it up there so that we can finish up, what we started. So that's what we're going to do. Taking this off. We're going to solve it up. We're solving this. Don't forget, we're solving this in alkaline medium after finishing the whole thing in acidic medium. So this is it. A 6 electron, 1 atom, 1 electron, I beg your pardon. So how do we balance it? Elimination method. We times this by 1, times this by 6. So 1 times all this will give us, Cr2O7, 2 minus, then plus 21, molecules of water, then plus 6 electron equals to 2 chromium that we have on this very spot here, 2 chromium here, which is 3 plus. So right here we have 14 OH, 14 hydroxyl, then plus 14 water. So then that's that for equation 1. Then equation 2, just 6 is going to multiply all this. So 6 Fe, that's 2 plus aqueous. Then plus, that's, I beg your pardon, minus 6 times this is minus 6 electron equals to 6 Fe3 plus aqueous. So everything is well set out. So C's here and C's here, you're going to add up the whole thing to eliminate this electron. So what do we have left? We add up the whole reactant, we add up the whole product. So Cr2072 minus aqueous plus CFE2 plus aqueous plus 21 molecules of water, that's water liquid. Then 2Cr3 plus aqueous plus Cs, this aqueous also, then plus 14 hydroxyl ion plus 14 molecule of water. So what are we going to do next? The next thing we're going to do, we're going to collect our lactants. We have plus 14 molecule of water on this very end. We're going to send it over to this place, to balance out the whole thing. So we've done already Cr2072 minus aqueous plus Cs, Fe2 plus aqueous. Then when plus 14 molecule of water crosses to this place, 21 minus 14 gives us plus 7 H2O. And 2Cr3 plus Cs, Fe3 plus 14 hydroxyl ion. So this is how to balance this in alkaline medium. As simple as that. So we've come to the end of the very lesson, although it looks quite complicated, quite complex, but very, very easy. So this is how to balance, complex redox equation in both acidic and alkaline medium. So if you gain one or two things from this very lesson, I'll love you to give me a follow on Facebook at Revelation Hub and subscribe to this very channel at EduMosaic. And don't forget, we have more on the way. So see you in the next lesson. Thanks and bye for now.